Hi. Okay, so by now you should know when talking about components of vectors, you should know why we need them. We need them so that when we add two vectors that are weird angles, um, we can't add them like that. So what we do is we break apart the vectors into their components. So, for example, this force 1 will be broken apart into a force 1 in the x direction and into a force 1 in the y direction. That fx and that fy combined actually represent the same thing as this one vector. Okay, so I break it apart and then I can do math with it. That's why we're breaking it apart into components. And you should know instinctively, what does the component, what do they mean? So the fx is how much of this force is actually pushing in the x direction. The Fy would be what portion of these 46 newtons are actually pushing in the y direction. Okay, so that's what it means. Today we're going to talk about the math with this video, and basically, how do you just do the numbers? Okay, so here we go. Let's start. We're going to start by giving an overview. I'm going to take that force 1 and I'm going to break that force 1 into its components. Okay, so it's going to be force 1 in x and force 1 in y. Let's actually do some colors here. So that I'm going to do green for that, and I'm going to do yellow for force 1 in y. Okay, so let's start. First of all, let's do this graphically. So I'm going to redraw this. It's not going to match. My drawings are not to scale. Don't get upset with me. Okay, so I have my force 1 is equal to 46 newtons. Okay, and we said that it's at 35 degrees. Okay, so what am I doing? I'm basically going to break this apart into a force 1 in the x direction. Actually, we said we'd do green, right? So green. A force 1 in the x direction, which I don't know, I'm estimating how long it would be. And okay, a force 1 in the y direction. And that will start somehow here and it'll go up. Okay, F1y and F1x. So what I am breaking this apart into two pieces, and these two pieces combined actually are the same thing as this one thing. And if we want to look at it on the drawing, how strong would that force be? Well, we can look at it graphically. We're going to calculate it later with the calculator. But for now, you could, if you drew this to scale, you could bring down the shadow of this thing as if there's a sun at high noon, okay? And it brings down the shadow, and that length actually represents the x component. Likewise, if I want to find the y component, I would imagine there's a sun really far away and it produces a shadow in the y direction, and I would have something like this, and that would be my force 1 in y. Okay? So graphically, that's the way to look at it. Okay, so I'm going to erase this just quickly because I want you to see that this force, this blue force, force 1, the original force, is equal to the x component plus the y component. Okay, so here I'm going to redraw that a little bit over so we can do our math. Okay, so let's get started with some calculations. Okay, so the first step is I have to find the real value of the angle. Now you say, oh, I have 35 degrees. Yes, but we always have to measure the angle from 0. 0 is here, right? 0 degrees. That's a little hard to read, but you get the idea, okay? You have to measure from 0, from the x direction. So when I do the angle, I need to be able to find from there. So if I start here, I would have to go 90 degrees to be pointing up plus the 35. So my full angle would be 90 degrees plus 35 degrees, which is equal to 125 degrees. Please do not skip that step, because if you use this number, it's wrong. Your angles always have to be measured compared to east, which is 0. Okay, that's the first step. And then the rest is just straightforward math. F1x is equal to the magnitude of the force, which in this case is 46. Magnitude is the number, times the cosine of the angle. The force 1 in y is the magnitude of force times the sine of the angle. And you will never be given these equations, but they're not hard to remember. Okay, so you will practice it so much you won't have to memorize anything. So let's do this. We're going to plug in the numbers. So 46 newtons times cosine of 125 degrees, and that is equal to 46 newtons times the sine of 125 degrees. And you could do this in one shot, but I want you to see something that's important. So I'm going to leave a little gap here. Okay, so when I do the cosine in my calculator of 125, cos 125, I get minus 57.35. So 46 newtons times minus 57 point, minus 0.57, whoops, minus 0.5736. And here I end up with 46 newtons times sine of 125 gives me 0.8192, let's say. 8192. Okay. Let's do it. Now, when I do that calculation, times 46 equals, in this one I get 37.68 newtons. And when I do this one, I end up with minus 26.38 newtons. Okay? Okay. So, what does this mean? So this is the math. That's how you do the numbers. You should know a bit of the meaning. What does this mean? It means that if I start off with a force 1, which is equal to 46 newtons at 125 degrees, that is equivalent to this force, okay, that force, plus this force, right? And this is acting along the x direction. So there's my F1x, and this is acting in the y direction. Let's look and see if our numbers make sense. Well, I have a negative here. That tells me that this x force actually goes to the left. Okay, does that make sense? Yeah, if I look over here, whoops, green. If I look over here and I am actually going to the left, so it should be negative. 26 is about half of 46, not quite. It's a little over half, actually. Yeah, this length should be about half. That makes sense. Likewise, the y component is 37 newtons. It's positive. Yeah, my force is going in a positive direction, right? It's going up that way. And it is 37, which is closer to 46 than my x. Well, that makes sense because my angle, 35 degrees, is shallower towards the north. It's actually pointing more north than west. So if it was at 45, the x component, the y component would be the same value. But since it's pointing more north, it makes sense that more of this 46 newtons is actually helping to the north. And It is. 37 is larger than 26. So my numbers make sense, right? Just instinctively. So that is how you calculate the components in the x and y direction. Now I'm going to do very quickly for force 2, and instinctively you can do it without doing any calculations. You should be able to see that, hey, force 2 is acting at 0 degrees, right? So all of this 58 is in the east direction. So my Fx of 2, force 2, is the full 58 newtons. All of it's pushing along the x-axis. However, in the y direction, none of this is pushing up or down. So the y direction, the F2y, is 0. If you do the calculations, and just for fun, this will just take a moment, we're going to do force 2 is equal to 58 newtons at 0 degrees. And if I break this apart into components, just like before, force 2x, force 2y, and I do the calculations, force 2x is equal to the magnitude of force 2 times the cosine of the angle, which is equal to 58 newtons times cos of 0 degrees. If you do the calculation, you will see that this is equal to 1. And 1 times anything is the full value, which is 58 newtons. Likewise, if you do this, you will find newtons times sine of 0 degrees. That sine of 0 degrees is 1. Do it in your calculator, you'll see I'm right. Oh, sorry, 0. Whoops. So sine of 0 degrees is 0, and 0 times anything is 0. And that makes sense, right? So F2y is equal to 0, and F2x is equal to the full value. Now, hopefully you're starting to see that this part of the calculation is interesting. Okay, this is the percentage of the total that actually contributes in the x direction. So if this value is 1, it means that my entire force is pushing in the x direction. If this value is 0, it means that 0 of this force is contributing. So all this means is that this section, okay, this section for the x and the y part, I'm going to have some F2y is equal to the magnitude of the force times the sine of the angle. Okay, that sine and cosine part is basically a number between 0 and 1 that tells you the percentage of the original force that contributes along the axis, whether it's the x-axis or the y-axis. This actually, the value, just so you know, I like to think of it between 0 and 1. It actually does all the way from the other way, from 0 to -1 also, just to show that if the direction is to the left for the x or down, right? So for example, here, this value is between 0 and 1, okay? But it's actually between -1 and 0, too, right? Just to show you that it's going to the left. But the main idea is that the magnitude of this value is between 0 and 1. So it tells you the percent of the total that contributes. So out of the 46 newtons, 57.57, which is 57% of these 46, is actually pushing in the x direction. Okay. So this value, we said, is the percentage. So 57%, about 57% of the total force is pushing that way. When I multiply 0.57 times the value, I get, 26 newtons are actually pushing in the x direction. So hopefully that helps you calculate components of forces, and it gives you an idea of what this cosine and sine functions do. Hope that helps.